All right, let's look at fluid resistance, and we're also going to talk about terminal velocity with fluid resistance involved here. So using fluid resistance, so there's basically two types. Now it should tell you which type we're using. You might have to make a graph to figure out which type. So for low speeds, you're going to have the force of resistance here proportional to the velocity to the first power, and it's going to be in opposite direction of the velocity. So sometimes you'll see a negative here. This is just a magnitude equation, so I don't have it. Or you might see it as proportional to the velocity squared. Again, this is a magnitude one, but otherwise, this one you didn't need the negative because it gets squared out. So that's why we kind of leave it out there. So the first thing you do is, in order to use these, you're going to have these coefficients of fluid resistance. Now this is dependent on the shape of the object, the density of the object. These types of things will affect your B and D value. I don't think it's density. Let's go ahead and start that one over. Let me look that up. All right, we are going to look at, let me start that over. We are going to look at fluid resistance. So there's two types of fluid resistance we can deal with, and I'm using this F here to represent the resistive force of the fluid. And it's equal to either BV or dV squared. So you'll notice one's dependent on the velocity, one's dependent on the velocity squared. These are magnitudes, so we better say speed here. B and D are dependent on the shape of your object. So how aerodynamic might it be, for instance? And what fluid are you going through? Am I going through water or am I going through air? All right. So for low speeds, you're typically going to use the BV, and for higher speeds, you're going to use dV squared. You're either going to have to do some sort of graphing, some sort of test to see which one it is, or it will be given to you. It'll say, hey, this is a proportional to V squared problem. Now, how do you use it? Now, how you use it is just like we've used friction in the past. I'm going to do a free fall problem here just because it's the most common. So I got gravity acting down, and I have this air resistance acting up. And so you draw it on there just like it is a force, because it is a force. And then you start summing up your forces. You might say the sum of the forces in the y direction equals ma. And it's always helpful for me. I like to do it. I like to choose the direction of my acceleration as positive. If you want to choose up as positive, that works just the same here. And so I end up with mg minus this bv. Now note, this is speed here. This is going to be important when we start to do other stuff. ma. So in this case, my velocity will be a positive value. Okay? And that's why I like to choose my acceleration as positive here as well, because then that takes care of that. So this is how we use it. If it was dV squared, I would just use dV squared when I substitute in. Okay? Now, how do we work with terminal velocity? So terminal velocity, Vt, occurs when the acceleration equals 0, because terminal velocity is the maximum velocity something will go given whatever force is pushing it and the resistive force, because the faster you go, the resistive force gets bigger. So we can go two directions. If we use the BV method, I find out that the acceleration is 0, so I get mg is equal to bvt, where that's my terminal velocity, and so vt is mg divided by b. If I'm more of a high-speed route, dv squared, my terminal velocity is going to be mg is equal to dv squared. And so then we solve for the terminal velocity, and we get the square root of mg over d. Okay. And again, when I'm talking about terminal velocities here, I'm talking about the speed. You would have to assign a direction later on if you needed. Okay. But in my case, I chose down as my positive direction, so these would be positives in both these cases. All right, if you want to see how do we get a velocity versus time function, we're going to go ahead and show that in the video link down below.